What's up, everybody, and welcome to another video. In this video, we're going to take a look at how to diagnose power door lock system in a car. This is for a Mazda 3. This is the wiring diagram for the Mazda 3. I already went ahead and removed the cover, the door cover, and this is the connector that we are going to take a look at. Behind that connector, inside the door, inside the frame, is the door lock actuator. Uh, the door lock actuator is controlling the door lock knob, and that's one of the wires here, and the other wire is for unlocking and locking the door using this latch here. Also notice that when the door is open, you have that light on the instrument cluster indicating that the door is open. All right, so let's take a look at the wiring diagram. This wires here is for that connector. Okay, so the first thing that we're going to take a look at is this contact here, which is the lilac and white wire. I believe lilac, that's the right name. It could be lilac. Is a white and black wire, and this contact is for the opening and closing of the door. Once the door is closed, that contact, it is switched to ground, and the voltage will go from, I believe, 11 volts to 0 volts. So right now it's sensing that the door is open. So I'm going to put my positive lead on this wire here, which is this first wire over here. Okay, and notice that I have 10.911 volts. So using a screwdriver, I'm going to try to activate the lock of the door. Right, so using a screwdriver, I'm going to try to close the door. Okay, so now notice that the light is not on anymore, and the voltage went from 11 volts to 0 volts. Okay, so that is one thing. As soon as you open the door, the voltage should go back to 11 volts, and the light should come back. Okay, so that is the first thing. It doesn't have one. And then on this side, this contact move to one side of the other one, depending on whether the door lock knob is closed or open. So let me go ahead and open the door. And for that, I'm looking for a lilac and black, and the other is brown and yellow, which are these two wires here. I'm going to put it in the brown and yellow. All right, so notice that when it is in this, I'm taking the measurement from this connector, from this wire right here, and when it is in this position, it is unlocked, and at that point, the voltage on this wire is being shorted to ground, so we shouldn't have any voltage there, and effectively, we don't have a voltage there. So when we lock the door, the contact is now moving to this side, so we should have a voltage here. And it moves to 4.5. So if we unlock it, it should back to ground. It should go back to ground. Okay. So that is the other thing that I wanted to show you. Okay, and the last thing that I wanted to show you is how the motor that controls the locking and unlocking of the door lock knob works. It is this motor here, It is controlled by the BCM using a double relay. Uh, by default, both sides of the relays are connected to ground, and depending on whether you want to lock or unlock the door, it changes the flow current. So when it is locking the door, current is going to flow in that direction. So this side stays connected to ground, while this side switches to 12 volts uh, power supply, and vice versa. So I'm using an oscilloscope for this, and when I lock the door, let's wait. That's for the lock, unlock. Okay, and I have the oscilloscope placed on the lilac red wire and the yellow red wire, which are those two wires there. I don't know if you guys can see it. Lock, unlock. Uh, I have it in the 200 milliseconds per division, so I'm guessing it's about 400 milliseconds. Let's see. Yep, two squares, 400 milliseconds, and it is a 2 volts per division. So I believe that's one. Let me do it again. That's one, two, three, four. 4 times 2. It's about 8 volts, 8, 9 volts.